Up until now, our code's been running on a pretty straight track, right? Just one line after the other. But what if we could give it a brain? What if it could make decisions, react to different situations, and even repeat things all on its own? Well, today, that's exactly what we're going to do. We are unlocking the brains of our code.
Let me put it this way. A simple program is kind of like a player piano, you know? It plays one song the same way every single time. But what we're talking about today, control flow, is what turns that piano into a full-on synthesizer keyboard. It gives us the power to improvise, to react, and to create really dynamic apps that can handle pretty much anything.
So here's the game plan. We'll start with the big idea of what it means for code to think. Then we'll see how it asks really simple questions. From there, we'll look at how it acts on the answers, how we can make it do things over and over, and then, the best part, we'll put it all together and build a real quiz game.
Okay, so the official name for all this is control flow. And really, it's just a fancy term for the tools that let us control the order our code runs in. Instead of just a straight line, top to bottom, we can now create forks in the road, little detours, and even loops, directing our program exactly where we need it to go.
But here's the thing. Before our code can make any kind of complex decision, it has to start with something incredibly simple, a question that can only be answered with a yes or a no. In programming, we call this true or false. And this, right here, is the absolute bedrock of all logic in code.
So how does our code ask those questions? With these symbols right here. These are our comparison operators. The double equal sign, that asks, hey, are these two things the same? The exclamation point equals sign asks, are they different? And of course, you've got your classics, greater than, less than, and all their variations. These are the basic tools for comparison. And here's the key. Every single time our code uses one of those operators, the answer it gets back is something called a Boolean value. It's not a number, it's not a piece of text, it's just true or false. That's it. This simple two-option answer is the foundation for everything that comes next.
All right, so our program can ask a question and it gets a true or a false. Big deal, right? Well, yeah, it is a huge deal because now we can turn that answer into an action. This is where the magic really starts to happen.
And this is the main tool for the job, the if statement. It's really as straightforward as it looks. We are literally saying to the computer, if this condition, in this case, age is 18 or older, is true, then and only then do you run the code that's indented underneath. If it's false, the program just skips it and moves on.
But, you know, life isn't always a simple yes or no. What if you have multiple possibilities? That's where elif, which is just short for else if, and else come in. The computer checks the if first. If it's true, awesome. It runs that code and the whole block is done. If not, it moves on to check the elif. And if nothing above was true, the else block is our safety net, our catch-all.
Okay, listen up, because this is super, super important. This is maybe the #1 trip-up for new programmers. A single equal sign means assign a value. It's like saying, put this thing in this box. A double equal sign, double equals, is asking a question. It means, are these two things the same? Mixing these up will cause you headaches, I promise. So burn this one into your brain.
So making one decision is cool, but the real power, the thing that makes programming so amazing, is automation. It's doing things over and over and over again without having to write the code every single time. And to do that, we need loops.
Now, there are two main kinds of loops you're going to use. A for loop is your go-to when you know exactly how many times you need to do something. Like, for every single item in this list, do this. A while loop is for when you don't know how many times. You just want to keep doing something as long as a certain condition is still true. Here's a perfect example of a for loop from our quiz game. We've got a dictionary full of questions. The for loop just says, hey, for every single key in that dictionary, I'm going to run this block of code. It'll just chug along one by one until it's gone through all of the questions. So simple, so powerful.
And here's the while loop doing its thing. You can basically read this in plain English. As long as the player wants to play again, keep starting a new game. We have no idea if they'll play once or 100 times, so the while loop is perfect. It just keeps checking that condition and running until it's told to stop.
All right, enough theory. Let's get to the fun part. We've looked at all the individual pieces, the comparisons, the if statements, the loops. Now we're going to see how they all snap together like Legos to build a real working program. This little chunk of code right here, this is the heart, the brain of our entire quiz game. It's a function called check-answer, and you can see, right in the middle, it's making a decision with that if-else statement. This is where the core logic lives.
So let's just walk through it. The function gets the right answer and the user's guess. Then, that if statement uses our friend the double equals operator to ask, are they the same? If the answer is true, it returns 1 point. If the answer is false, the else part kicks in and it returns 0. See? Every single concept we just talked about is right here in these few lines.
And that's the magic. You have the for loop handling the repetitive work, asking every single question, while the if statement inside our function handles the smart part, the decision-making. One handles the repetition, the other handles the logic, and together you've got a complete game.
So, you now have the fundamental building blocks to make your programs intelligent. They can evaluate things, they can choose different paths, they can automate boring, repetitive tasks. This is the difference between a simple little script and a real application. So the only question left is, what are you going to build first?